Hello everyone, welcome to our YouTube channel Kanad Shastra. In today's video lecture, we are going to discuss semiconductor. As far as the electronics components are concerned, semiconductors are the most important types of material. They have conduction properties which are in between those of conductors and insulator. That means we can say that semiconductors are neither conductor nor insulator. And also the forbidden gap is very narrow as compared to that of the insulator. Semiconductors are a material which have a conductivity between conductors and insulator. If we see the classification of semiconductor, then it is classified in two types. Basically, one is intrinsic semiconductor and second one is extrinsic semiconductor. If we further classified extrinsic semiconductor, it has two types, p-type semiconductor and n-type semiconductor. Now we can discuss each type thoroughly. If we are talking about intrinsic semiconductor, then intrinsic semiconductor means pure semiconductor. That means it is the purest possible form of the semiconductor. Silicon and germanium are the example of intrinsic semiconductor. And also the presence of impurity is as low as much possible in the intrinsic semiconductor. Also, if we increase the temperature or the application like voltage does not increase their conductivity significantly, therefore the intrinsic semiconductors are not practically used for the manufacturing of devices. So which semiconductor is used for the manufacturing of devices? So it is extrinsic semiconductor, which is used for manufacturing of the devices. Now we discuss extrinsic semiconductor. Extrinsic means impure. Extrinsic semiconductor means impure semiconductor. If we add some impurity in intrinsic semiconductor, then we get extrinsic semiconductor. अगर हमने इंट्रिंसिक सेमीकंडक्टर में कुछ डोपिंग की या फिर इम्प्योरिटी ऐड की तो हमें एक्सट्रिंसिक सेमीकंडक्टर मिलता है. Impurity is nothing but the some other material, and the process of adding impurities is called doping. Doping means what? It is the process of adding impurities. Why we are adding impurities? We are adding impurities to increase the conductivity of semiconductor, because we see that the intrinsic semiconductors, if we increase the temperature or the application like voltage of the intrinsic semiconductor, then the conductivity is not significantly increased. So that we use extrinsic semiconductor and we get an extrinsic semiconductor by adding impurity to the intrinsic semiconductor. So we are doing doping for the increasing conductivity of the semiconductor. So after doping, the conductivity of extrinsic semiconductor are increased. Therefore, they are used in the manufacturing of the all electronics components such as a diode, transistor, etc. The two types of extrinsic semiconductors are the p-type semiconductor and n-type semiconductor. This type of semiconductors depends on the type of impurity being used. जिस प्रकार की इम्प्योरिटी हम यूज़ करते हैं या इंट्रिंसिक सेमीकंडक्टर में ऐड करते हैं, उस पर एक्सट्रिंसिक सेमीकंडक्टर के टाइप्स डिपेंड होते हैं. कंडक्शन इन इंट्रिंसिक सेमीकंडक्टर. We have seen that at absolute zero temperature, the intrinsic semiconductors behave like a perfect insulator. But this behavior can also change when we increase the temperature. So with increase in temperature, this behavior changes. At around room temperature, electrons become available for conduction and current can flow. So in following figure, the valence electron go to conduction band due to the absorbed thermal energy. So this is intrinsic semiconductor, and we are applying heat or light energy to it. So what behavior changes? We are going to see that. So this semiconductor material has a valence band and conduction band. This is the energy band we can see. So in a valence band there is a electron. Suppose 4 electrons are there, and in conduction band also there are some electrons. Now what happen when we increase the temperature or applied some voltage? Many valence electron will absorb the thermal energy, breaks the covalent bond and go into the conduction band. Means these electrons will absorb the enough energy and go to the conduction band, and then they are free. So that free electron are called conduction electron. And when this happens, that means when an electron breaks a covalent bond and become free, a vacancy is created in the broken covalent bond. Means these electrons going in conduction band, so here the vacancy is created. So if we see that this vacancy, so vacancy is created, and these vacancies is called hole. Thus corresponding to every free electron a hole is created. That means if this second electron is also go to conduction band, then here also the vacancy is created. If third electron is going to conduction band, again third vacancy is created, that means third hole is created. Therefore the number of free electrons generated due to increased temperature is exactly equal to the number of holes. So this is the free electron, this is the holes. As the free electrons and holes get generated in pair, they are called as a thermally generated electron hole pair. That means this vacancy, it is this vacancy and free electron is called electron hole pair, and both electron and holes can operate as a charge carrier. The hole is said to be positive charge as it is nothing but absence of an electron, that is vacancy. The generation of electron hole pair is C here, so that the conductivity of intrinsic semiconductor increases due to the increase in temperature. Also, the effect of light incident on the semiconductor is the same as that of the heat or the voltage applied. Extrinsic semiconductor. To increase the conductivity of intrinsic semiconductor, we have to apply the heat energy or the light energy externally. We just see that. These methods of increasing the conduction are not practically useful, hence the conductivity is increased by means of doping process. We just see that the method of increasing the conductivity of the intrinsic semiconductor, but that is not a proper method to increase the conductivity of the semiconductor material. We have another one method is doping to increase the conductivity of semiconductor material, and that method is called doping. So doping is the process generally in which we are add some impurities. So doping is the process of adding impurities. Impurities is nothing but some other materials. In this process, impurities are added to the pure silicon or germanium. Two types of impurities we are adding. One is donor impurities and second one is acceptor impurities. These donor impurities are also called pentavalent impurities. and these acceptor impurities are also called trivalent impurities. Pentavalent impurities are phosphorus, arsenic, and antimony. And trivalent impurities, that is acceptor impurities, are boron, gallium, indium. These are the trivalent impurities. Also, there is a one concept, that is dopant. So, what is dopant? So, dopant means the material which is being used as an impurity in the process of doping is called as dopant. That means if we see the trivalent dopant, then boron, gallium, indium are the dopant. And in pentavalent impurities, phosphorus, arsenic, antimony are the dopants we use in a doping process. In the classification, we see that the two types of extrinsic semiconductor, N-type semiconductor and P-type semiconductor. So, N-type semiconductor is formed by adding a small amount of pentavalent impurity to the pure silicon or germanium material which act as a base material. If we adding the pentavalent impurities like phosphorus, arsenic and antimony to the pure silicon or germanium, then this create the N-type semiconductor. And in other words, for P-type semiconductor, if we adding boron, gallium and indium to the pure silicon or germanium, then it becomes P-type semiconductor. Now we see that what happens when we add these pentavalent impurities or these trivalent impurities to the pure silicon or germanium atom. Now we can see how N-type semiconductor are formed. So this figure shows the formation of the N-type semiconductor. When a pentavalent impurities such as arsenic is added to the intrinsic semiconductors, 4 valence electron of arsenic atom form 4 covalent bond with 4 valence electron of the neighboring silicon atom. So in this figure we can see that these arsenic atoms has a 5 electron in its valence shell. 4 electrons are having covalent bonding with the 4 silicon atom. The 5th electron of the arsenic atom does not have a chance to form a covalent bond. This is an additional valence electron which can enter the conduction band very easily to be a free electron. Thus, corresponding to each impurity atom, an extra electron becomes available for the conduction. So, the extra or the 5th atom of every arsenic atoms are available for the conduction. So, this increases the number of electrons and it makes the semiconductor as a N-type semiconductor. As we also know that if we are adding a pentavalent impurities, it becomes the N-type semiconductor. And it is possible to control the number of free electrons available for the conduction, so that 5th electron, by changing the number of pentavalent atoms added to the silicon material. This conductivity is also increased in the controlled manner with the help of doping process. So in this way we can form a N-type semiconductor. Likewise, if we want to form a P-type semiconductor, then we have to add the trivalent impurities to this silicon atom. So instead of this arsenic atom, if we add trivalent impurities like boron, gallium or indium, and which has a 3 electrons, then we form a P-type semiconductor also.